Every street, every light, every pulse is part of a living equation.
Most people see a city of lights. I see a rationale for research.
6 million lives are held together by a fragile system of linear equations.
At Nazitech, we don't just solve for X. We teach you to keep the heart of this nation beating.
This is the intersection of real-world data and mathematical logic.
Initiating simultaneous equation analysis.
At Nazitech School, mathematics isn't memorized, it's engineered.
Welcome to Nazitech School, where theory meets tomorrow. Let's begin.
Singapore is a living equation, but right now, the variables are fighting back.
No, these loads should balance. Ooh, that face again. Something's broken. Not now, Aurelius.
The system is rejecting a variable. Which one?
The city's pulling power from itself. That's impossible.
Impossible is just math that hasn't introduced itself yet.
The total load is critical.
Financial district, residential hub, same total load, different behavior.
Kaelen, let me handle this.
That should hold. I said balance. I didn't say peace.
Substitution fixed the numbers, but the signals are colliding.
Some variables hate sharing the spotlight.
Aurelius, they're duplicated.
Ooh, my favorite kind of mess. Then we eliminate, shall we?
Silence the duplicate to hear the individual.
Y equals 2 and X equals 4.5. Interference gone.
We are at the 0 point. This is where the lines of our lives actually cross.
They're opposite directions. Now watch where they agree.
The equations are balanced, Kaelen. For now. Logic isn't just about math. It's about finding where we meet.
Every city is a system. Every system is a set of variables.
Hi, welcome to Nazitech School Mathematics Laboratory. I'm very certain that you will enjoy this mathematics lesson, just like the movie you just watched.
Hi.
Today, we will be applying the simultaneous equations to optimize bus and MRT routes for the city. Now, let's begin with this IGCSE question. A bus and a train start at the same station. Together, they cover 100 kilometers × 100.
So tell me, what could X represent here?
Distance covered by the bus.
And Y by the train.
Together, they cover 100 kilometers. The train covers 20 kilometers more than the bus. Solve for X and Y. By substituting Y, 2X is equal to 80. This means that the bus covers 40 kilometers and the train 60 kilometers. Our scope is set. Students, can you figure out the ticket prices before we plug in?
Yes, sir.
Sir, I substituted x to y plus 4 into 2x plus 3y.
So y is equal to 2 and x is equal to 6. The cross data is now verified.
Good job. Where does substitution always begin? To solve this, push the expression for x into the first equation.
Therefore, y is equal to 30 gigawatts and x is equal to 70 gigawatts. Now, the power is balanced. Two signals, one bottleneck. Which variable must go? Watch closely, this is elimination in motion. Plug it back in and y is equal to 3.5. This is one more question to go. Students, let's get to the scene of interest.
This intersection is the only place where the budget meets demand. We have our solution.
In math, as in life, we seek the point where all variables find harmony.
You've successfully navigated the intersection of shadows.
Now download your worksheets and keep solving those simultaneous equations.
Follow us on our social media platforms. On our YouTube channel, subscribe, like, and comment.
At Nazitech School, our students model systems, test limits, and justify every decision. Because when energy is balanced, movement matters next. And every journey begins with the right model.